Hi everyone, I'm Tim Kington and this is Coding is for the Birds. Daisy and I are working our way through building a JVM. Today we're going to dig into type conversions. We've created a couple of conversion opcodes, and if we continue down that path again, we're going to have a bunch of classes. But I think it's much easier to just create a single convert op and have a switch inside it that handles these types. So let's do that. So it's 85 to 93. And I think we're just going to create a convert op. So let's call it convert op, and we'll give it the opcode so that it knows which types we're converting. And we'll copy one of these, I guess. We'll make this our convert op. This is going to need a private byte opcode. Need a constructor. And then in here, we're going to need a switch. And then we're going to have a bunch of cases in here. So let's get rid of our case down here. We have a D to I and I to D. Those are handled in the if now. And we're going to get rid of our other conversion opcode. This can leave. And then we need to know about this in our convert op. All right, so 85 is I to L. I to L is going to require a push long. So we're going to say push long stack.pop. We're going to pop the integer, convert it to a long, push it, and we're done. And then here we should probably comment these just in case they're not perfect on the first try. Okay, I to F is 86, and we're going to get the integer. I guess that's probably going to be in a lot of these. And then we need to convert it to a float and convert the float to its int representation and push that. So we're going to push float.float to Ryan bits. Float version, well, I guess that always takes a float of val. All right. And I guess this could have been stack.pop if we want to do it in one line. Let's not get too clever. I to D. All right, so 87 is I to D. We're going to get an int, then we're going to convert it to a double and push that. So push double val. That's really all we need there. I guess these need operation, don't they? And we have to pass the stack in there. What's the problem here? It's push long, yes. That's right. This is push long, and the value is going to be the double. You know, I think even though that push double was a one-liner, I think it's nice to have. Let's put it back. this is because it needs the stack. All right, L2I is next. So here we need to pop along. We have a pop double. This is really pop long here. Okay, we're up to L2F, 89. So we pop along, so long bell has to go out here. And we're converting it to a float. So we're going to do a push, float through on it bits, long bell, and to pass this in here, I guess it's going to let us do that. So the long got converted to a float. That kind of surprises me. I'm going to put a cast in here just in case. That seems real suspicious. I guess I should move this down here. It's going to be easier to see what's going on. We've knocked out these 5. All right. L to D. Pop along, push a double. Apparently converting that to a double doesn't require a cast. I'm kind of wondering if something's wrong here. F to I. So this is going to be a float. I guess we're going to put in a pop float. And then this is going to be an int. So we're going to say stack.push float bell. And now it should require a cast. If this one doesn't, I'm going to think I've lost my mind. All right, so this one I do need to cast to an int. And we do need to add a pop float here. And it's int bits to float. Okay. Now something went wrong with my numbers. Yes, this should have been 8A. And this should be 8B. Okay. Now we're on F to L. Float gets pushed the same way, but now we need to push it long. Okay. D. This one's a double. I guess I don't need that cast because converting a float to a double is free. D to I. So this is going to be pop double. Need a double val. So we got a double, and then we're going to convert it to an int. What's unhappy? Too many parentheses. Okay. Those two are done. Double to long. Get a double. Push long. This was a mistake. Did I mess any others up? I to L, pop an int, push it as a long. I to F, pop an int, convert it to float bits and push it. I to D, we get an int. Okay, so this is wrong. That needs to be pushed double. Long to int, pop a long, convert to int and push. Long to float, pop a long, convert to a float. We can make this a push float. We're going to have to do this more than once. So this is push float stack long val, and it's converting our long to a float again. It really just makes me nervous. I guess it's happening. I mean, I don't think it could be doing the wrong thing. All right, long to double, pop a long, push double, the long as a double, pop a float, convert to an int. Okay, float to long, pop a float, push it as a long, float to double, pop a float, push double, double to int, pop the double, convert to an int and push it, double to long. Okay, this should not be an int, this should be a long. Okay, just a few more to do here. 90 is D to F. Double, push a float. And if we don't have a cast here, it ought to complain. Okay. We need an I to B. So this one's going to be an int. So val is stack.pop. And then we're going to do a push byte of val. Now that's kind of weird. Oh, it's because of the auto boxing. I guess we can do it like this. Okay, and then we have I to C and I to S. I to C. This is char, and then this is too short. Okay, so that should take care of our conversions. What's going on back here? That import is wrong. Okay. First, let's see if our tests still pass. We did test D to I and I to D at least. Uh-oh. We broke it. Unknown opcode. Okay. Yeah, this is because of the weirdness with bytes and ints, I guess. So this needs to be byte x85. All right, now we need some tests for these conversions. How are we going to do this? All right, we're going to start with I to L. So let's get an integer. And we'll put it in our first local. And then we're going to do some conversions. So we'll do an iload. And then we need to do our I to L, which is 85. And then we're going to store the long, which is this. So we'll store it at 1. And now we're expecting to have a 1 here and the long of 1. So it should be the high bits and the low bits, right? It should be a 0 and a 1 here. All right, let's do this again. So we're going to test I to F, 86. So we're going to load our int from slot 0. We're going to convert to a float. We're going to store it. We need an F store, which is 38. So we're going to say 38 and store it. 0, 1, and 2 are taken by the first 3. So now we need 3. And we'll return, and now we need to see a float here. So this will be float val. Or no, this is an int. Int float val equals float to raw int bits of 1. And we need 4 locals now. All right, that's I to F. I to D we need to do, so we'll do a load, we'll do an I to D, and then we need a D store. Here's a D store. And 0, 1, 2, 3. So we need to store at 4. That's correct. And now we need to get our double values. So let's say int array double parts is split long of operation dot, I guess not dot, but double dot, double the raw long bits of 1. So we've got the pieces we need for the double, and then we'll take double parts sub 0 and double parts sub 1. Just to see something break in our test, I'm not going to update max locals, just to make sure we're really running this code and testing what we think we are. Okay, so we'll make that 6 now. We want an L to I next. So these are tested pretty well with the value 1, right? I to long extended it with zeros, which is what will always happen. I to F and I to D are changing it to these different formats, and those are getting checked now. What we really need to do here is load a long from the constant table. It needs to be too big to fit in an int. So let's just make sure if we write some code that does that, that we have the right opcodes. So this is going to be in hex 10,000. Is that right? That can't be right, can it? No, these are 4 each. Yeah, so it's got to have 8 zeros. 1, 2, 3, 4, 5, 6, 7, 8. Yeah, there you go. Won't fit in an int, so it didn't like that. And then here we're going to do this type conversion. That's fine. So save and run this. And then we can go look at what Java P tells us. All right, so we are using the LDC2W that we already have here to get our long loaded. So we should be able to handle that. I think that we're probably going to run into a new constant type that we haven't handled. Yeah, so tag 5 is a constant long, I would expect. Yeah, 5 is a constant long, and it's high bytes and then low bytes in our class file. So it's just like our constant double. We're going to need to handle that. And I guess it's going to take 2 entries too, which is kind of dumb. All right, so we need our const long here. And we need a long constant class. And it's going to look something like this one. It should be a long. And when we need to push it on the stack, we're going to call push long, right? So and then back here, the imports read long doesn't exist, I guess. Let's fix that. So if we run this, something happened. Okay. Now we can be fairly confident that we have the right stuff in place because we're seeing a 1 there, right? So we got 1 into x, but then our conversion to an int may not have worked here. Oh no, it did, because it'll be 0, right? So really this constant, we want this to be something like that so that there's something left in the int part. And so we can see that the long now has a high order part of 1 and a low order part of 2, and then y becomes just the integer 2. So that looks pretty reasonable. So now we have to do something like that in translator test. So we're going to need that LDC2W thing. Yeah, we need this kind of thing. This will load along. Okay, so maybe I should start breaking these up just to make this easier to read. So I to D, and then L to I is next with 88. Yeah. Okay, so this is going to be 88. This LDC2W is loading from the constant pool at a certain index, right? So this is index 1, and if we want to have a constants pool, then we're going to need to set this up. And when we call exec, we'll pass that in. And then we're going to need to add a long constant. And this is going to be hex. Let's do the 1, 2, 3, 4, 5, 6, 7, and 2. Which is too big for an int, so that's good. And then we're loading constant 1, which will be this one. We're going to do an L to I, and then we need to do an I store. And this was stored at 4 and 5, so we need to store at 6. We need an I store 6. Where's an I store with an argument? Here we go, it's 36. So 36, this is I store 6. And now we need 6 and 7, so that's 8 locals. And then this we should probably start breaking up. This is going to be, we're going to have 1, and then we're going to have a long 1, and we're going to have a float, then we're going to have some double parts, and then we're going to have the leftover int from that conversion, which will be a 2. Right, so only the low part is going to survive. And I guess we didn't need to increase this by 2. This should be 7, right? So 0, 1, 2, 3, 4, 5, 6. Okay. Let's see if this works. Can I click this to run it? So maybe it's just the first time you add a new test it doesn't work correctly. So that passed apparently. That was L to I. Now let's do L to F. So we'll load the same long. We're going to do an L to F, 9, and then we need to do an F store, which is 38. And it's going to go at 7 and 8. Not 7 and 8, just 7. It's a float. Okay, so now our next value should be, so this was a long of this value. That got converted to a float. I don't even really know what that's going to be. So I guess I'll do it this way. We'll say long to float. We're going to actually do it ourselves. Just as that, lambda float is the float version of that. So whatever that is, that's what we're expecting. And so here we'll say float to bits of long to float. This is what we'd expect to see. And we forgot to increase our number of locals. Okay, that's L to F. L to D. So we go get our long. We're going to do an L to D. 8A. Then we need to do a D store. 8. So that's an 8. Our D store is 39. Now that's going to store the two parts of that double. So I think we'll do the same thing here because I'm not completely sure how that's going to work. So we'll say long to double, the double version of long const. And then we need an int array long to double parts is split. This guy, and then we'll put these here. And we need to add 2 to this. Okay. F2I. Now, where are we going to get a float? If we want an interesting float value, again, we're going to have to look at what the real compiler does. So let's do that. Float x, 1.23 maybe? And then we'll convert it to an int. So if we run this and take a look, we're getting a load constant. So that's an ordinary LDC. There is some kind of load constant opcode that we haven't implemented yet, but I guess we don't need it quite yet. So I'm going to do this. And it'll be constant 2, I guess. So we're going to add a new float constant. In fact, we may run into another constant problem because we haven't had a float constant. Yeah, we do. Okay, so let's take care of that. Constant floats of 4. We need to handle it here. We need a new type. And here we need to create a float from it. So this is int bits to float. This. So we need a new constant class. And it's going to look kind of like our integer constant. And then we don't push value, we're going to push float to int bits. Okay. And then back in parser, need to import that. I think that should be okay. Let's go ahead and run it again, see what our output is. Okay, so we got some sort of a float here. That seems plausibly correct. Okay, so here, if we're going to use a float constant, we need something like this. And we'll say 1.23. And then we're going to need the bits of that. So we'll say all right, so we have float constant, which is our second constant now. So we're going to do load constant 2. Then we're going to do our float to whatever it was. 8b is float to int. And then we're going to do an iStore. And it would be an iStore 10, which is 0a. And iStore is 36. So now we're going to see 11 locals, and the last one ought to be that float to int value. Okay, we got an empty stack exception in our convert op. Yeah, we messed up. This is supposed to be 8b. Oh, also that's, yes, the test was wrong too, right? So we're not going to, we're not going to see the floating point bits here. That's wrong. We've converted to an int, so this should be a 1 because we converted our float 1.23 into an int. Let's make this something that's not 1. Just 1 is too easy to have by accident showing up in your output. So let's make it 3.14, say. Now it should be converted to 3 because we're truncating it to an int. Okay, so that worked. We can do F to L, which is 8C. And then we need an LStore 11. And LStore is 37. So now 11 and 12 will be the value for 3. So we have the high bits and the low bits. Okay, and then F to double is 8D. And we need a D store at 13. D store is 39. Okay, and this is going to be the double value of 3, right? So the pieces of that will be double 3 parts. So we'll have these two things. And was at 13, so this becomes 15 now. Interesting. This one, so we have two things that are wrong here. Something's wrong. So we need the double version of 3.14 here. Got to be careful. Not quite right. We need the double version of 3.14f. So that isn't quite the same. And we're going to need to convert this float into a double and then split it up so that we're doing the same thing that actually happens in our code. All right. That was a tricky one. So float to double. Okay, double to int. We're going to need a double constant now. So let's create that. This can be 7.813. And when we deal with that, we're going to need to do the wide load. And it's going to be constant number 3. And then it's D2I is 8E, right? Okay. And then we need an I store, 36. And we'll store it at, so 13 and 14 are taken, so we need 15, which is F. Another 16 of these. And we'd expect our double 7813 to get converted to 7 when we make it an integer. And it did. Let's put these down here at the bottom. All right, double to long. So we load our double, we do a double to long. And then we're going to do a long store at 16. And that's a 37. And that means we're going to get the long version of 7, right? So 0 and 7, I guess. All right. Double to float. Load it, double to float, do an F store, 18. F store is a 38. So we load the double, double the float, store the float at 18. And then we're going to need that value. So that, and then this will be float to run bits of the double to float constant, and we need another slot in our local variables table. Okay, 3 to go. Int to bytes, int to char, and int to short. So we're going to need an int constant, which we will load like this. So load constant, and it's going to be constant 4, I guess, right? We have 3 already. Yeah, so this will be constant, and I guess we'll have a variable for that. This is going to be something in hex. I guess we could do something like this. That'll make it easy to tell what is going on as we reduce the width. So that's our integer constant. We're going to load that. 91 is I to B. And then we're going to do a store. Now there is no byte store, right? This is just going to be an I store. So I store is a 36, and we're going to store it in slot 19, which is 13x. Okay, so then we expect to get the byte version, but our local is really an int. So what we're going to get is this truncated to a byte, which will be 78 hex. Okay, and then we can do the same kind of thing for the other two. So we have a I to C and I to short. So this is I to char. 92. We'll store this slot 20. And then we need I to S, which is 93. And we're going to store this in slot 21. Done with all of these, and then we need a couple more entries here. So the one that's a char would be the same as the one that's a short, right? So they're both going to be 5, 6, 7, 8. I'm kind of unclear on why there's a difference between those two opcodes. It might be for some of the class file validation stuff. Let's take a look at I to C. I to C is the oddball. We pop it, truncate it to char and 0, extend it. That's going to be our difference, isn't it? I to S is sign extended. Okay, so that's actually interesting. We need to be a little careful here. So these are being sign extended. Then we need to make sure we're trying one that will have a high bit on and a high bit off. So I to B gave us 78 hex, which is not big enough. Let's do this again. Here we want the high bits to be on for both of these. So let's do a EF here, and then these can be CD. So CDEF is good. And now we need to make sure those signs got extended, right? So int const 2. Okay, so let's add another integer constant. And we're going to add a couple more tests here. So we'll do another I to B, and we'll store it at 22, I guess. This is loading constant 5, though. And this loads constant 5, does an I to C, and stores it at 23, which is 17x. And then our short, we need to double this one up, constant 5, and store it at 24. All right, so the next three values now should be a sign extended and here. So this is going to be that, not 7, 8, it's EF. And then for our char, the char was next, right? For the char, it will not be sign extended. So this is CDEF. And the short is FFFF CDEF. I think that's going to work. The highest was 24, which means we have 25 of these. Or I don't know if it's going to work. It's going to test the code correctly. Okay, so it looks like, I mean, I guess in the convert operation, I used the Java conversion, so they're doing the right thing already. But we needed to check that. Well, that took a while, but now we can handle converting between any two primitive types. And along the way, we also picked up the ability to handle a few constant types that we hadn't handled in the past. Thanks for watching. Don't forget to like and subscribe.